Have you ever stood on a shore, looked out at the vast, endless ocean, and just wondered what lies beyond the horizon? There's a certain pull, isn't there? A deep human need to know. We've been doing that for centuries, looking up at the night sky, which is our cosmic ocean. And in 1977, we did something remarkable. We took a bottle, put a message inside, and cast it out into that great dark sea. That bottle is a spacecraft named Voyager 1. It's more than just a machine of metal, wires, and scientific instruments. It's a testament to our curiosity. It's an extension of our senses, reaching out into the profound blackness far beyond where any human has ever gone, or could hope to go in our lifetime. Voyager 1 is our silent ambassador to the galaxy. This spacecraft carries with it the hopes, dreams, and profound questions of a small blue world. It was designed to explore, to discover, to report back on the nature of our solar system's outer planets. But its mission grew into something much larger, something almost poetic. It became a pioneer, the first human-made object to push past the familiar boundaries of our sun's influence and venture into the unknown territory between the stars. To truly appreciate what Voyager 1 is doing now, we have to look back at where it came from. The mission was born from a rare celestial alignment, a grand tour opportunity that only comes around once every 176 years. This alignment allowed a single spacecraft to use the gravity of one giant planet to slingshot itself to the next, like a cosmic game of billiards. It was an incredibly ambitious plan. So, in the late summer of 1977, Voyager 1 lifted off from Cape Canaveral, Florida, its sights set on the two largest planets in our solar system, Jupiter and Saturn. It was a journey into the realm of giants. Its first major encounter was with Jupiter in 1979. The images it sent back were breathtaking and completely revolutionized our understanding of the gas giant. We saw for the first time the intricate, swirling details of the Great Red Spot, a storm larger than our entire planet. We discovered faint, dusty rings around Jupiter that we never knew existed. And perhaps most astonishingly, we found active volcanoes erupting on its moon, Io. After its triumphant flyby of Jupiter, Voyager 1 sailed onward to Saturn, arriving in 1980. Once again, it rewrote the textbooks. It revealed the stunning complexity of Saturn's rings, showing them to be composed of thousands of individual ringlets, braided and kinked by the gravitational pull of tiny shepherd moons. It gave us our first close-up look at Titan, Saturn's largest moon, revealing a thick, hazy, nitrogen-rich atmosphere, tantalizingly similar in some ways to Earth's early atmosphere. This encounter with Titan was a critical part of its mission, but it came at a cost. The trajectory needed to study Titan sent Voyager 1 careening up and out of the plane of the solar system, ending its tour of the planets. From there, its mission changed. It was no longer a planetary explorer but an interstellar scout. On February 14, 1990, at the request of the great astronomer Carl Sagan, NASA turned Voyager 1's camera around one last time. From a distance of nearly 4 billion miles, it took a final family portrait of our solar system. In that image, Earth appeared as a tiny speck of light, a pale blue dot. It was a humbling, poignant reminder of our place in the cosmos, a single pixel in the vastness. So, where is Voyager 1 today, on this day in 2025? It is in a place no human-made object has ever been before. It is in interstellar space. In August 2012, after a 35-year journey, it finally crossed the heliopause, the turbulent outer boundary of our sun's influence. It left home. Imagine that. It is now floating in the medium between the stars, a realm dominated not by the solar wind from our sun, but by the ancient remnants of stellar explosions that happened millions of years ago somewhere else in our galaxy. It is truly an emissary in an alien environment, a place where the rules are different and the cosmic weather is entirely new. The distance to Voyager 1 is almost incomprehensible. As of today, it's over 16 billion miles, or about 26 billion kilometers away from Earth. Light, the fastest thing in the universe, takes more than 23 hours to travel that distance. This means when we send a command to the spacecraft, we have to wait nearly 2 full days to receive a confirmation that the command was received and executed. It's a slow, patient conversation across an unimaginable gulf of space. The spacecraft is moving at a blistering speed of over 38,000 miles per hour relative to the sun. yet the distances are so vast that it still takes centuries for it to travel even a fraction of the way to the nearest star. Out there, the environment is unlike anything in our solar system. The particle density is higher, and the magnetic field has changed its orientation, now aligning with the broader magnetic field of the Milky Way galaxy itself. Voyager 1 is our only direct source of data about this region. It's like having a single weather station in the middle of a vast unexplored continent. Every measurement it takes of the plasma density, the magnetic fields, and the cosmic rays is precious, giving us our first real taste of the galactic environment. It tells us about the stuff from which stars and planets are born, the very fabric of the cosmos that exists between the stellar islands. But the journey is taking its toll. The spacecraft is powered by a radioisotope thermoelectric generator, which uses the heat from the decay of plutonium-238 to generate electricity. That power source is slowly fading. To conserve energy, engineers on Earth have been systematically shutting down non-essential instruments over the years. Its heaters, its camera, and other systems have gone dark one by one. Yet, a few key instruments remain online, continuing to send back their precious data. Voyager 1 is old, it's cold, and it's running on fumes, but it is still working. It's a testament to the brilliant engineering of the people who built it, a machine that has long outlasted its original warranty. How then does a nearly 50-year-old spacecraft, billions of miles away, detect anything at all, let alone something new and unexpected? It doesn't have a powerful telescope or a high-resolution camera anymore. Those were shut down long ago to save power. Instead, Voyager 1 sees the universe through a different set of senses. It listens, it feels, and it tastes its environment. Its primary tools for this are its plasma wave system, its cosmic ray detector, and its magnetometer. These instruments are designed to measure the properties of the space it is flying through, the particles, the waves, and the magnetic fields that permeate the interstellar medium. The plasma wave system is essentially a set of antennas that function like cosmic ears. They listen for oscillations in the plasma, the soup of charged particles that fills interstellar space. When our sun lets out a massive burst of energy called a coronal mass ejection, it sends a shockwave traveling out through the solar system. Months later, when this shockwave reaches Voyager 1, it causes the interstellar plasma to vibrate, to ring like a bell. By listening to the frequency of this ringing, scientists can determine the density of the plasma. It's an indirect but incredibly clever way to measure the stuff that's out there. Another key instrument is the cosmic ray subsystem. Cosmic rays are not really rays. They are high-energy particles, mostly protons and atomic nuclei, that have been accelerated to nearly the speed of light by distant supernova and other violent cosmic events. Inside our solar system, the sun's magnetic field deflects many of these particles, protecting us from the harshest radiation. But out in interstellar space, Voyager 1 is exposed to the full, unadulterated force of these galactic travelers. By measuring their energy and direction, it helps us understand their origins and the powerful processes that create them throughout the Milky Way. The magnetometer, as the name suggests, measures the strength and direction of magnetic fields. Inside the heliosphere, the magnetic field is generated by our sun. But once Voyager 1 crossed into interstellar space, it began to measure the magnetic field of the galaxy itself. This field is incredibly weak, but it's there, and it shapes the structure of the interstellar medium. By combining data from all these instruments, the plasma waves, the cosmic rays, and the magnetic fields, scientists can build a multifaceted picture of this unexplored region, piecing together clues to understand the physics of the space between stars. It's through this careful, patient listening that new discoveries are made. And that brings us to the news that has the astronomical community buzzing with quiet excitement. In a recent analysis of data collected over the past few years, scientists carefully studying the faint signals from Voyager 1 have identified something completely unexpected. As the spacecraft has continued its journey through the interstellar medium, its plasma wave system has been picking up faint recurring signals. These aren't the loud ringing tones caused by solar shockwaves. These are much subtler, more persistent whispers. After painstakingly filtering out known sources of interference and natural plasma oscillations, a clear pattern emerged. 775 distinct, localized sources of plasma density fluctuations. What this means in simpler terms is that Voyager 1 appears to have detected 775 objects or structures of some kind floating in the interstellar void. These are not solid objects in the way we think of a planet or an asteroid. They are more like localized clouds or disturbances in the interstellar gas. They are regions where the density of the plasma is just a bit higher than the surrounding empty space. The spacecraft hasn't seen them with a camera. It has heard their faint electrical signature as it has flown past them or near them. It's a discovery made not by sight, but by sound, a testament to the power of listening to the cosmos. The sheer number of these detections is what is so staggering. Finding one or two anomalous structures would be interesting. Finding a handful would be a significant discovery. But finding 775 of them suggests that the interstellar medium might be far more structured and clumpy than our previous models had predicted. We used to think of interstellar space as a mostly uniform, thin soup of gas and dust. This new data from Voyager 1 paints a different picture. One of a complex, dynamic environment filled with countless small-scale structures. It's like we thought the ocean was perfectly smooth, and we just discovered it's filled with millions of tiny, unseen eddies and currents. This discovery wasn't a single eureka moment. It was the result of years of meticulous work by the Voyager science team. They had to develop new data processing techniques to pull these incredibly faint signals out of the background noise. They had to account for the spacecraft's own aging electronics and the ever-present hiss of galactic radio waves. It was only after cross-referencing data from different instruments and ruling out every conceivable alternative that they became confident in their conclusion. Voyager 1, in its twilight years, has once again opened up a new window onto the universe, revealing a hidden population of objects we never knew existed. So, we've found 775 mysterious somethings out in the space between the stars. You might be asking, why is this important? It matters because it fundamentally changes our understanding of the interstellar medium, the very stuff our galaxy is made of. This medium is the galactic reservoir from which new stars and planetary systems are born. It's also the graveyard where the material from old, dying stars is returned. Understanding its structure, its density, and its dynamics is crucial to understanding the entire life cycle of stars and galaxies. This discovery suggests our picture of that reservoir has been incomplete. Think of it this way. If you want to understand the weather patterns on Earth, you need to know about more than just the big high-pressure and low-pressure systems. You also need to understand the small-scale phenomena like clouds, thunderstorms, and tornadoes. These 775 objects could be the interstellar equivalent of small-scale weather. They might be tiny, dense knots of gas that play a critical role in the larger cosmic ecosystem. They could be the missing link in our theories of star formation, the very first seeds from which giant molecular clouds, and eventually stars, begin to collapse and form. Furthermore, this discovery has profound implications for our understanding of how galaxies evolve. The interstellar medium is not static. It's constantly being stirred and shaped by powerful forces like supernova explosions and stellar winds from massive stars. These newly discovered objects could be the remnants of such events, like cosmic shrapnel scattered through the galaxy. By studying their distribution, their size, and their density, we might be able to trace the history of violent events in our galactic neighborhood. They could be fossils, preserving a record of the galaxy's turbulent past for us to read. And finally, this finding reinforces the immense value of in situ exploration. We can study the universe with powerful telescopes from Earth, and we learn incredible things. But there is no substitute for actually going there. No telescope on Earth or even in orbit could have detected these faint, localized plasma structures. It required a spacecraft to physically fly through that region and touch the environment. Voyager 1's discovery is a powerful argument for continuing to send probes out into the unknown. It reminds us that whenever we push the boundaries of exploration, we find things that surprise us, things that challenge our assumptions and force us to think in new ways. The moment a discovery like this is announced, the big question on everyone's mind is, naturally, what are they? The honest answer, at this point, is that we don't know for sure. But science is all about proposing and testing hypotheses, and there are several intriguing possibilities that astronomers are now considering. It's important to approach these ideas with a healthy dose of scientific skepticism and excitement. The most likely explanations are rooted in natural astrophysical phenomena that we are only just beginning to understand. This is where the real detective work begins, sifting through the clues to find the most plausible solution. One leading hypothesis is that these are interstellar plasma clouds or density filaments. Imagine the interstellar medium not as a smooth fog, but as something more like a cloudy sky, with wisps and clumps of denser material floating within it. These could be turbulence-driven structures, formed by the chaotic motion of gas stirred up by ancient supernova shockwaves. They would be invisible to traditional telescopes, but would have just enough density to be detected by Voyager's sensitive plasma wave system. This idea is compelling because it fits well with modern theories of plasma physics and turbulence, suggesting the interstellar medium is a much more dynamic and frothy place than we once thought. Another possibility is that these are the remnants of dying, low-mass stars like white dwarfs. When a star like our Sun dies, it sheds its outer layers, creating a beautiful planetary nebula. But what happens to that material over millions or billions of years? It disperses and cools, eventually becoming incredibly faint and diffuse. It's possible that Voyager 1 is flying through the ancient, shredded remains of such stars. These stellar ghosts would be far too faint to see, but they might retain enough of a density signature to be picked up as the spacecraft passes through them. This would be a fascinating find, giving us a new way to study the end-of-life stages of stars. Of course, whenever we find something unknown in space, the mind naturally wanders to more exotic explanations. Could these be something truly alien? It's a tantalizing thought, but it's important to remember the scientific principle that extraordinary claims require extraordinary evidence. There is currently no data to suggest these objects are artificial. They are far more likely to be a new and fascinating but entirely natural feature of our galaxy. The universe is a weird and wonderful place, and it has proven time and again that it can produce phenomena far stranger than anything we could have imagined. The search for answers will be a thrilling scientific journey. This discovery does not mark the end of a story. It marks the beginning of a new chapter. The immediate next step for scientists is to dive deeper into the Voyager 1 data archive. The team will re-examine all the data collected since the spacecraft entered interstellar space, looking for more of these signals that may have been missed. They will refine their analytical techniques to better characterize the size, shape, and motion of the 775 objects already identified. Every scrap of information will be scrutinized for clues. Is there a pattern to their distribution? Are they clustered together, or are they spread out randomly? These are the questions that will occupy researchers for years to come. A crucial part of this investigation will involve Voyager 2. Voyager 1's twin spacecraft is also in interstellar space, having crossed the boundary in a different location in 2018. It is following a different path and is equipped with a similar set of instruments. Scientists will now be eagerly looking at the data from Voyager 2 to see if it detects similar structures. If it does, it would provide powerful confirmation that these objects are a common feature of the interstellar medium and not just a strange anomaly local to Voyager 1's path. If it doesn't, that would be just as interesting, suggesting the interstellar environment varies significantly from one region to another. Looking further into the future, this discovery will undoubtedly influence the design of future interstellar missions. Scientists and engineers are already dreaming up concepts for probes that could travel faster and farther than the Voyagers, reaching interstellar space in a fraction of the time. This new finding gives them a specific, compelling scientific target. A future mission could be designed with instruments specifically optimized to map out these density structures in 3 dimensions, to analyze their chemical composition, and to understand their role in galactic evolution. The Voyagers have shown us the way. The next generation of explorers will follow in their wake, equipped with new questions and new tools. Ultimately, this story is about more than just 775 objects. It's about the enduring power of human curiosity. We sent a probe into the unknown, not because we knew what we would find, but precisely because we didn't. And now, nearly 50 years later, it is still rewarding that curiosity with fundamental discoveries about our place in the universe. The journey of Voyager 1 is a mirror of our own journey as a species, always pushing at the boundaries, always looking over the next horizon, driven by an insatiable need to understand. It's a journey that connects us to the cosmos and reminds us that there is always more to explore. Thank you for joining me on this cosmic journey today. The universe is waiting for us. If you, like me, believe in the power of exploration and the thrill of discovery, I invite you to become part of our community. Support our mission to bring the cosmos down to Earth by subscribing to Cosmic Discover. Together, let's keep looking up.